Thank you, everyone, for joining us. I am Brian DeLuca, along with Nicoletta Mino, and we'll be your host today for this live chat, simplifying the power design process for medical applications, sponsored by Sega Electronics and Recomm Power. We have some great panelists in this live chat, and make sure you ask your questions in the Q&A at the bottom of your screen, because we will be taking your questions live during this event.
All right.
Now to Nicolette.
Yeah. Hello, everybody. So like Brian said, today we're talking about simplifying the power design process for medical applications. And these days, medical applications have strict regulatory requirements in both hospital and non-hospital environments due to their high-risk nature. This means the corresponding electronic equipment must be held to elevated standards of safety and reliability. So today we're joined by Peter Victoria, applications engineer at Recomm Power, and Rick Hauk, Power Solutions sales engineer at Sager Electronics, to learn more about simplifying power design processes for medical applications. This is everything from clinical medical equipment like diagnostics, monitoring, and laboratory, to home healthcare and patient care equipment. We'll also be chatting about how custom solutions distributors help aid the design process and complement power products from Recomm. So let's get started. First, thank you both for joining us. Thank you for your time.
Absolutely.
No problem. Happy to be here.
All right. So why don't we kick off? Why don't we dive in by talking about the medical safety standards that exist? I don't know who wants to kick us off there, Peter?
Yeah, I'll take that one. So the primary medical standard is IEC 60601 -1. So IEC is basically the international standard, but there's also local versions that cover USA, Canada, and Europe as well. But that's pretty much the granddaddy.
So, sorry, did you want to say something else, Peter, on that?
No, go ahead.
Okay.
Yeah.
So at a high level, what do engineers need to know right now about power design medical applications?
Yeah, so the that safety standard I just talked about, that pretty much dictates all the requirements for either the power supplies or the other equipment as well. So since I'm the power supply guy, I'll talk on that. So basically, the biggest thing is having reinforced isolation. So that's having multiple layers of insulation between the primary side and the secondary side of your transformer that's going to be inside the power supply. And that's super safety critical. So that's basically eliminating any kind of leakage current or, accidental electricity from flowing into whoever's, either handling the equipment or a patient who's actually on the other side of it completely. So that's kind of the big thing. There's other subcategories that we can go into later if we need to, and different editions of this standard. And those things dictate, whether it's actually applied to the patient, whether it is operator protection, whether it's in the vicinity. So there's a lot of different things, as well as like EMC that we can go into.
Do any of these standards kind of pose a challenge to engineers? I mean, what types of challenges are the engineers really up against when they're designing for this type of equipment in terms of these safety standards?
Peter, you want to take that one, or Nick?
Yeah.
Well, I would say then you're approaching on the method of patient protection, method of operator protection, BF rated or CF rated.
Exactly. So to kind of expand on that, so that has to go into the means of protection is what it's called. So typically when you're dealing with the Recomm product, you're seeing something called 2MOPP, which stands for 2 means of patient protection. And that just means that it's basically the most safe, that has stricter requirements than the operator protection. So in order to do that, engineers need to be able to design their product to have minimum leakage currents. So I believe for BF applications, which stands for body floating, they need an isolation voltage of around 4,000 volts AC. That's tested for about a minute. And then they need to also worry about the creepages and clearances. And the creepage is the distance between the shortest distance between two pins just on a path on a surface, and the clearance is the two distances through the air. And these distances are either 5 or 8 millimeters, depending on what they're going for. So it can be kind of tricky to design a cost-effective and small device while also meeting these requirements.
So now getting rid of heat is a big challenge in power supply design also, correct? Let's talk about convection and conduction and recent restrictions around moving air through medical facilities.
Yeah, so I can pull up, actually I got a couple slides here.
Sure.
One moment, that kind of demonstrate a couple of our parts and how they operate, whether it's conduction or convection cooling. Sorry, there we go. All right, hopefully that's coming through. Yeah, so it's going to be situational for every part. For us, we have a lot of different DC to DCs and AC to DCs. Typically, the AC to DCs are higher power, and for the higher power applications, it's more critical to dissipate heat just because in nature they get hotter. So here's an example of a 1200 watt we have. This is an AC to DC converter. So for this part, we've actually done a pretty good job with the thermal design. And on the left side here, you can see the performance for just conduction cooling, which is definitely more attractive now. It's a quieter solution and it's simpler, less components to worry about. You don't need to design in a fan and worry about venting that airflow and all that stuff. Yeah, so for this particular part, we'll look at this black line basically. And this represents the voltage here in the US, so 120. So this is really an 800 watt supply with just pure conduction cooling. So there's a base plate attached to this part, but customers will need to implement either a heat sink or some other kind of base plate to basically help dissipate the heat this is generating. So this is pretty good with that airflow. I'd say probably one of the best out there on the market. And then if you do need airflow, if you do need that little bit of extra power, there are options with the fan. And then you can see you can get an additional 200 watts basically here in the US. But like I said, when you're working with the fan, you need a way to vent this and making sure that the hot air is just not spinning around, basically in the same place. So yeah, so there's a whole bunch of different parameters that are data sheets and that I can help out with if anyone's looking at a Recomm part. So whether they're looking at the base plate temperature or the ambient temperature, there's a few different things.
So what's so this 1200 volt, right? What type of equipment does this go into? Like, what would this be used for in medical equipment?
Yeah, so this is used in a lot of different things. So one big one is medical beds. So for a lot of those, they're powering a lot of equipment. It might not be the full 800 watts the whole time. It may, to actually raise it, it may need to kick up in power. And this one's actually capable of doing that. So you'll see the peak power here for 4 and 10 seconds, we can get up to 1200 watts. So that's one example. This is also in dialysis machines and used in surgical equipment. So, and all that stuff requires that BF rating that we kind of talked about earlier, which is the body floating. So this part is, with that BF rating, this part can actually be connected directly to a human body, and it's completely safe. It has all the certifications there. Yeah, also we see this in a lot of medical lighting. They need very bright lights, so it's good to have high power solution for that as well. Yeah, so those are just a couple examples I have off the top of my head for this one.
Thanks for sharing.
Yeah.
I was thinking though, maybe we should break down some of these requirements a little bit more for the audience. What are your thoughts on that?
Sure. Yeah, we can go into that. Yeah, so like I mentioned at the top, there's a few different additions with this. So currently we're on the 4th edition. I guess I can kind of work backwards. So the 4th edition of 60601 currently covers EMC so electromagnetic compatibility requirements. And this is pretty critical, especially as we start seeing more home healthcare applications. So the tests are there to make sure that, you know, the power supply doesn't malfunction. In the case, you know, we're surrounded by electricity everywhere,
Right.
you know, your stove, your refrigerator, you know, everything. So it's very important that in those kind of environments, the power supply doesn't fail or give a false reading or, you know, set any kind of alarm, a false alarm or positive false, you know, anything like that. So basically 60601 and the medical EMC standard, I should say, is 60601-1-2. So basically this is close to the industrial EMC standard, except that, you know, basically failure really isn't an option. You know, you'll see with some of those other ones, there's different criteria that say, okay, well, if the part isn't damaged, you have to manually restart it, you know, that's okay. That's not really the case on the medical side. So it needs to be pretty bulletproof. And with a lot of our power supplies that we have, you know, that comes all together. So you don't really need to worry about designing any external filtering or anything like that. Yeah, so that's the fourth one. The third and the second one kind of go hand in hand. And this is related to the BF and CF topics we touched on. So BF is body floating equipment connected to someone's body. CF stands for cardiac floating. And this has to do with any equipment connected directly to someone's heart. So this could be monitoring equipment or like a pacemaker type thing.
Right.
And those each have different leakage current requirements. So I think for BF, it's around 100 microamps, and for CF, it's about 10 microamps. So extra safe, making sure that no electricity goes through and, you know, accidentally injures someone, you know, that kind of stuff.
Right.
And the last one has to do with the vicinity, or I guess it's all related to the vicinity. The other one is just body or just B. So this is, you know, not connected to the patient, but around the patient. So this would be like the medical bed I talked about. Maybe there's equipment underneath that's close, or the medical lighting. There's also different requirements for this to make sure all the equipment's safe and, you know, no one's going to get hurt and it's all reliable.
So now, are there certain, like, you know, with the different types of devices, are there certain, like, you know, you talked about the leakage, is there certain like size restrictions or voltage restrictions on some of the parts that are used, or it's just really the leakage that we're looking at?
Yeah, so the leakage current is probably the most critical thing that they're looking at. You know, just in case, and there's a couple different kinds. You know, there's the kind where you're actually the part is being applied. There's a part where, oops, I accidentally bumped into the equipment, kind of thing. And that's really the main thing I think these guys are looking at. And they test leakage current at different isolation voltages.
Okay.
So usually 4,000 volts is typical,
Gotcha.
the typical test voltage. And the other thing that comes up a lot in the medical world is the working voltage, which is kind of like the continuous voltage between the input side and the output side. And that's around 250 volts. So you'll see a lot of medical parts referencing that working voltage. So that's also another thing people are looking for a lot, and something that Recomm covers.
So we have a question here from a participant in the audience who's asking if you can go over the differences between class 2 and 3, especially how to connect, I'm not sure here, EGND to chassis.
Do you want to take that one, Rick?
Oh boy.
I know we have class 1 and class 2 devices.
Correct.
If we're talking about the ground class, right?
Right. The difference between having earth ground with a class 1 and the extra isolation of no earth ground with class 2. So,
right. So I know that for I can speak on the class 2 and the class 1 side of things. So basically everything we do on the AC to DC side is going to be class 2, which means that you don't need that protective earth ground, and that's due to the construction of the transformer. So basically, since it's all double insulated, so the idea is that if there was a short circuit there, the ground would provide a return path, so it wouldn't shock anyone. But with the class 2 equipment, that's something you don't really need to worry about, since it's all taken care of internally. We do have one class 1 part with the PE, but I think that's really more for EMC purposes.
Okay.
But yeah, so but basically, it's, yeah, to sum it up, the class 2, you don't need the ground pin, and with class 1, it's usually a requirement. That's what I would say.
Or yeah, I would think with the what I kind of depicted as earth ground abbreviation in there, but there also is the differences between a class 1, class 2, or class 3 medical device.
Okay.
Okay.
So you know, the class 3 is by far the most stringent life support. Class 1 is something probably as simple as a splint. Class 2 is, I'm going to say, something like a CT scanner, something like that.
So,
And,
you know, sorry.
and I would say definitely for a class 2 medical device, you know, if it's number 2 versus Roman numeral 2, the Roman numerals kind of tell us as designers that that's got to do with protective earth ground. The number 2 then tells us the classification of what the medical device would be.
I get it. Okay.
So here's a question. I'm just sort of looking at, you know, that user's question also. They're talking about connecting, I guess, the ground to the chassis. Is that only like with certain parts, like that class 1 part where it's connected? You have the return ground, because the others you said are handled internally, correct, Peter?
Yeah, exactly.
Mhm.
Yeah, so for the parts that we offer, I think we have one that it specifically has that PE pin that's connected all the way to the chassis for that return path. But everything else, yeah, usually the ground is floating. So yeah, we don't have a ton of options like that. But yeah.
Sure. Now, are there any alternative solutions that haven't proven effective in conforming to these standards that we've been talking about?
Not that I'm super aware of. I know there are some ways to get around the testing or around the requirements with additional testing. But again, that just takes a lot of time and effort and working with UL and the certification houses to get around all that stuff. So typically it's easier just to go with the standard or picking a part that, you know, is already fully certified and comes certified, you know, with all the paperwork, and you're ready to go.
Oh, that raises then maybe a question about Recomm's products, because you guys have a ton of solutions that suit medical applications. So maybe you could talk about those solutions and give us some examples of how you're meeting that need. Sure.
Yeah, so we have a wide variety of both DC to DC and AC to DC options that are medically certified. So the power ranges there on the DC to DC side are around 1 to 30 watts, and we're currently working on a 60 watt, so going higher in power. And on the AC to DC side, we go from currently 40 watts and then up to that 1200 watts that I showed you.
And Peter, that I think now is a good time. That I would say up until the last couple of years, even prior to when Sager had Recomm on our line card, and I'd run up against a Recomm socket, very popular in the DC to DC world. But you guys have really started to expand into the AC to DC open frame, which I'm very thankful for. So I think we should touch on a few of those as well.
Sure. Yeah. Let me share my screen again. And I'd love to talk about that. Yeah, so Rick, you're right. So in the past, historically we've been, DC low power has kind of gone hand in hand with Recomm. But lately we've put a lot of effort, and a lot of, hired a lot of design engineers who are, have more experience and are better capable of, expanding our portfolio. So yeah, here's a few different examples of kind of the, open frame, front end, off board, whatever you want to call it, AC to DC medical solutions. So starting on the left there, we have a 40 watt and a 60 watt. There are your two footprints, so 2x3 inch and 2x4 inch. And with these, there is really an emphasis on, driving down cost. So for a medical solution, which is typically, a premium part, and comes with a premium price, this one's actually very competitively priced. So these are all very good. These ones have kind of the Molex style connectors, but there's also an option for PCB mounting these ones as well. So these ones are kind of the transition area. And then more recently, we released this 130 watt or at peak power 130 watt, continuous 100 watt, in the 2x4 package. This one's going to be offered in an open frame or an enclosed version as well. I like to say that for most of the times, the enclosure for our parts are really there just to prevent people from bumping into them and injuring themselves, touching 120 volts. They don't really impact the performance too much. But for this part, this is the exception. It does. So there's actually a heatsink built in right here, and that helps move heat from the components into the enclosure. So this one actually does have better thermal performance. So yeah, that's 100 watt. Oh, go ahead.
Are these two kind of really designed for back to class 1, class 2 Roman numerals for the home healthcare? Obviously, it can go both ways, but is there an option of a class 1 part number and a class 2 part number, or is it one or the other?
So these ones are all going to be class 2
Okay.
as they come. There might be an option to add your PE if you want, like if you mount this on a chassis or something.
Mm-hmm.
But as they come, they'll be class 2.
Sure. So better targets, better applications for home healthcare.
Yeah, absolutely.
Okay.
And the other nice thing about a lot of our AC/DCs too is that they actually have the household certification as well, which is 60335. So that's also another set of requirements that these meet. So yeah, they can be in household applications as well.
So what are so for the first two you just talked about, right? What are some of the equipment these would be designed into? Like we talked about the 1200 volt one being designed into like beds and things like that. What would these, these other ones, the 40 and 60 watt and the 100 watt, be designed into?
Yeah, so these could be in a lot of different things. So I'm thinking like patient monitoring equipment, as well as I know we have some designs with not CT scanners, ultrasounds as well. So whether it's powering the actual ultrasound device that's being applied to someone, or it's the actual interface where you see the screen and it's all the data and all that stuff. Something like this would be a good fit there, maybe for some of the lower power applications within those guys. Yeah, so those are some good ones.
While you have the products up, I just had a thought. I'm sure we talk about size constraints. I mean, how do these parts kind of fall into that and help the engineers?
Yeah, so they're packed pretty densely on the board.
Mm-hmm.
So one of the that's one of the benefits about designing with a modular device is that, you know, this is all of our effort, right? So this is all we have to do. We don't have to worry about the ultrasound working and all that stuff. So we've gotten really good at making the design as compact as possible. So in the past, like a typical 40-watt part would be 2 by 4 inches, but you know, we're able to scale it down to 2 by 3 inches. And that comes with component placement, as well as managing all the thermals that we were talking about as well. You know, when you start shrinking the space, you get more concentration, so it's more difficult. So there's a lot of work that goes into the PCB design and layout as well, to help get these as small as possible, to help customers, you know, get it into their design. You know, they don't have to have a big old space. They can kind of fit it wherever.
Great. So speaking about size, we have a question from one user asking specifically, do you have a 600 watt in a 3 by 5 footprint? That's a very specific question from that user.
Yeah.
And
I guess
since
is they
it's
have a design ready to go.
Yeah.
That you need to like put this in, or something that's, you know, compatible, right? Where I guess you're in that 600 watt range in that 3 by, you know, 5-ish space.
So 3 by 5 is going to be hard to get for 600 watts. We have a couple other parts. I can pull them up real quick.
Yeah, that'd be great.
Show them off.
Because that is a very specific question.
Yeah.
Yeah.
Well,
that is someone.
I love that.
Right, that's someone that's looking for something right now.
Right.
Something. Thank you for that question.
That's definitely where the industry is going. Is what is going on in the semiconductor world is the faster switching speeds allow for smaller transformers, and everything is, I mean, look at what a 600 watt power supply was 20 years ago. I'm sure it was at least twice the size as it is today. And on this, well, okay, go ahead, Peter, on this one.
Yeah, so this is 600 watt. It's a little bit bigger than what you're looking for. So and the other thing is a lot of times this isn't the nominal value. That's just kind of an industry standard. That's kind of the peak value. So let's go down to the derating real quick. So this is really a 300 watt part with natural convection. If you have a fan or something in your application, then yeah, 600 watts would be possible. So I would say this is probably the closest match to the person asking the question. So RACM 600L would be the part number.
Yeah, and I'm sure they may have some reach out directly to you guys after this.
Yeah, please do. I mean, that's what we're here for. So I can work through anything with you guys.
You know, you have open frame up here on the screen, and I know we were talking about board level products before. Do we want to talk any more about open frame for the audience?
Yeah, the other one that I'd like to highlight is the 1200 watt that I kind of touched on earlier. It's like the open frame off board, you know, kind of front end kind of part. So this is a new one from our design team in Vienna. So this one is pretty much best thermal class or best thermals in its class. Sorry, I'm trying to find this. Okay. So yeah, so like I showed before, you know, this is pretty much as good as it gets in this package. If you look at some of our competitors, it's either same or not quite as good. And the other interesting thing about this part is it comes with the PM bus interface, which is similar to like I2C. So this essentially allows customers to either monitor the part or control it or configure it. So if they want to adjust the output voltage or they want to set a certain ramp rate for the output load, all these things are possible. Or, you know, if they want to be monitoring the output voltage or monitoring the temperature to make sure it's all good. That's a new feature for us with this part, and something we're really excited about, and we think it's going to help a lot of people out and meet a lot of different requirements. So this is definitely a good one, winner.
So what are some of the other advantages of using Recomm medical grade power supplies?
All
Right,
right.
we
So if
talked
you
about-
had to make a list, okay,
Right.
if you had to name like the
What is your
top,
bulleted list?
yeah, what are
Okay.
what are the advantages here?
Well, I think the biggest one is that you're getting a complete solution right off the shelf. So it really eliminates a lot of the design work that customers have to do, especially with all the AC/DCs I was talking about. Like I said, they're coming fully certified. All the internal protections are taken care of, so they don't need to worry about adding a fuse or anything like that.
Mhm.
It's all protected against surges. And then that really cuts down on their time to market. Usually the medical design cycle is pretty long, but if you can shorten it down and focus more on your application and not so much the power side, that's something that we definitely help out a lot with. And the other thing is that you get our support. So, I'm here to jump on the phone and answer emails for any technical questions. We also have an EMC team in Austria that's fully dedicated to resolving any issues there. So we can get on a conference call if you guys are having EMC issues or you just have general questions, and they can even recommend board layout changes, or add this filter if required for like a DC to DC. Sometimes they're required there. So yeah, I think those are the bullets, the value we're bringing.
And you get Peter. That's the
Right.
Yeah, I'm here.
Peter, his email is just going to be completely full. Outlook's going to shut down.
No, that'd be
So,
great.
So over the course of the past, half hour, we've talked about different medical applications, and maybe it would be helpful at this point to just, first look at a high level, what are all of those, home healthcare applications going on right now? Because that's a big one we, mentioned. And, to piggyback on that, maybe we can go forward facing and look at what the future of healthcare looks like and have a little fun.
Definitely.
Sure. So for the home side of things, obviously, like different applications could be like a CPAP machine, is a big one. But there's a lot of like recovery equipment, for athletes or people who are post-surgery. I just saw a guy who had this kind of this pack on him, and it had hot water and a cold water cycle, and it basically kind of cycled the water around to his injured area. It was pretty cool, and good timing for this. So there's a lot of things like that. I think probably the future would be kind of an area or some sort of device that's able to take vitals, so that way whoever is working with the whether it's a doctor or PA, they have a better idea. It's not just a verbal communication about how they're feeling. They can actually see the graphs and all that stuff.
Do you think a lot of those devices, like sort of future looking, are going to be, I want to say like IoT, but really connected to your phone at least, right? They're not necessarily going to be doing the compute power. They'll be doing like the data. They'll be collecting the data and moving to your phone and things like that. Versus being a device that's communicating.
I wouldn't be surprised if there's already a lot of this in R&D. I think with the strain that the medical industry has been under the last 2 years, we're all kind of, for simple things, if it's strep, if it's something that's not too severe, we're asked, log in, do a virtual call. But I definitely foresee in the future every home having a device that like Peter said, that you can put your hand on, you can do a cuff, like for blood pressure, whatever, and whoever is on the other side, whether it's a doctor, PA, whatever, is going to get better information to be able to diagnose some of those regular illnesses or whatever much faster,
Right.
From the home. And it's like normal clinical diagnosis, I think, is going to be able to be done virtually,
Right.
for sure.
I
So
think
we're
the
gonna
other
have we're gonna have this medical room. Like you walk in, it's not gonna be a utility room. You're gonna walk
Right.
in, you're gonna get scanned, you're gonna put your
Yeah.
hand down. It's gonna do everything for you.
Well, sure, bring the Jetsons to life.
You know, I have a question about cost in regard to this. So, I mean, you mentioned earlier, you were talking about cost, Peter, when you were looking at maybe this is a more economical option, or, keep the cost down. When we look at the future and we look at how, this could be something that's in every person's home, where does cost really come into play when engineers are designing? I mean, obviously everything costs money. Cost is, a concern for everyone, but how important is that, and how will that be changing as this becomes something that we anticipate could be in everybody's home?
Well, I think the cost of components are, usually going down, like Rick said. So as they develop better technology and better manufacturing processes, that makes it a little more cost effective for everyone. So I think we're just waiting on the technology and the manufacturing to get better.
Okay.
It's smaller, where less materials are required as well.
So eventually it would be something that's economical for people to have. It would be doable. It's not something out of reach.
Yeah,
Sure.
absolutely. I think so.
Well,
So
and it can help reduce costs in the medical industry as a whole. It's going to be easier for somebody, let's just say, that to do a simple physical to a certain point. If people do that more often to catch things far sooner, it's going to reduce the whole entire medical industry cost as a whole. So as far as maybe Nicolette getting to what we're dealing with in this call, as far as reducing the cost of equipment, like, yeah, definitely what Peter said, that with technology changing so fast, and it's generally the automotive industry and government and space that kind of do a little bit of the R&D up front on new technologies, and then that trickles down everywhere else. And it continues to happen, and it's going to continue to happen for the foreseeable future, for sure. So, I mean, I can remember 20 years ago, the first silicon carbide IGBT that was 100 amps was probably over $1,000. So all that stuff comes down. Like the very first LED from the 1960s was hundreds of dollars. Now those are pennies. So yeah, I think it's just going to be something that's going to help all of us in the future, for sure.
So I have a question, right? Is the design, as we're talking about this, is the design cycle time going to change? Because medical is traditionally a pretty long design cycle, as we were talking about earlier. Do you see as some of these home sort of healthcare pieces and some of these things we were, talking about in the future, do you think that design cycle is going to shrink?
I would say no, probably, because especially if it's going to the home, it's got to be really bulletproof, like you got to make sure that it's super simple to use, and that there's a real low chance of
someone hurting themselves.
Yeah, hurting themselves or messing it up, not getting the right kind of reading or whatever. So I think that the design cycle is always going to be long for those reasons. But once it's out there, and maybe the first time someone works on it and it gets, that takes a long time. But yeah, eventually, once it's kind of figured out, once it's more of a common technology, then I could see it, getting shorter and shorter, definitely.
So we actually have a couple of questions from the audience. I want to make sure we get to those. We have a late joiner who apologizes for being late, but just wants to know if you've already discussed the EMC class of these devices and if they are Class B emissions.
No, we haven't talked about that yet, but yeah. So on our AC to DC side, anything AC to DC we have, that's going to be all Class B. So which is better than Class A, which is good. And that's without any external components whatsoever. So that's all taken care of internally. And And for our parts, we always say compliant to Class B. So when we tested it, it's all good. We don't have the stamp of approval, but that's basically a way to give you confidence for when you go to test it, that it's good. And oftentimes EMC is very dependent on your application, how you're installing it. So, but yeah, the power supply itself is Class B. So we're good there.
We also have another question.
Well, actually, there's another
Oh,
question on
yeah, a
emissions for
follow-up.
Class B, right? It says emissions Class B with open frame. So I guess they're looking if you have an open frames Class B solution.
Yeah, anything anything AC/DC for us, our ACM that I mentioned is whether it's open frame or enclosed, it's going to pass Class B emissions. So you're all good there.
So we also have a user asking, if you connect two power supply modules in parallel to satisfy the load, do you need to recertify the combined power supplies, or the certification for the single module is enough?
Okay. So I guess it depends. It sounds like this person wants to use two power supplies in parallel to double the load maybe, or increase the power. So actually for our parts, there's not really any options there for load sharing. So that wouldn't really be possible without going into some sort of customization discussion. But you can use two in parallel for redundancy's sake. So if one pops out, the other one's there, it's all good. And I don't believe that impacts our safety certifications. It may be something that when you go to UL or whoever, they would look at that and make sure it's safe, and they would inspect our documentation. But I don't think, our documentation, we would have to add any additional tests for that.
Okay.
So Rick, So Rick, you and the Sager team work hard to support Recomm. Can you tell us a little bit about how that works?
Sure. So Sager Electronics, we've got 10 service centers around North America, and each with what we call PSEs, or power solution sales engineers. And we've all got a strong background in power, thermal, and battery applications. And we started this program probably about 8 years ago to be the first point of contact for our customers, and also internally for our field sales reps and inside sales support. And it's grown. It has really taken off. And if even internally, if I run up against an application, I've got about 12 other people within my little Teams chat that I can bounce stuff off of. And if I don't know the answer, I'll just go right to Peter.
Right.
And then just get back to the customer as soon as we possibly can. The other thing is I would say, last I checked, we had just over $1 million worth of Recomm inventory on the shelf, and that's pipelined constantly. And I think there's still about 800,000 available, and we've stocked about 400 of their most popular part numbers.
When we talk about that partnership, are there any other benefits there? Let's say maybe inventory or supply chain benefits, or that's a hot topic right now. What are some of those benefits of that partnership that Sager and Recomm forms?
I would say probably one of the biggest is the ability to buy in smaller quantities, and that's kind of one of the things that we offer is to carry inventory. So that if there's somebody either wants to look at a new part, even preliminarily, I'll go ahead and send them a couple samples to play with. Right. And then once it gets to a little bit more serious side, they've got some samples to test, and then prototype samples, or once they do start really testing it. So we try to getting back to a little bit of that design timeline. If we've got it on the shelf, and everybody knows lead times are astronomical right now, and they have been for a while. And I don't know if I foresee it really getting back to what we used to think of normal, 12 to 14 weeks for at least through maybe Q3 of 23 into 24. Hopefully then, they'll get back to that. But so that's why we try to pipeline product and have it on the shelf to help shorten that design cycle, and get them going with testing products. So from that standpoint, and also we've got our headquarters in Middleborough, Massachusetts, and that's I want to say it's 100,000 square foot facility that's got inventory, and so we ship from there. And then also we've got our facility in Carrollton, Texas, that is soon going to be moving to Louisville. And there we're going from 64,000 square feet to 175,000 square feet.
Doubling.
So
Yeah, nice. Doubling it.
Yeah. So to also shorten and lower shipping costs as well.
Now you also mentioned sort of testing, right? You guys, so if they're just prototyping, right, they could get like small quantities from you of power supplies?
Oh, for sure. Yes.
Okay.
Yep. We really don't have a minimum order, dollar amount or quantity. Yep. If they want one, we'll ship one.
So I guess, before we wrap up, as we're approaching the top of the hour, what are we not asking that we should be asking about simplifying the process, the medical design process for these applications? I mean, what are those questions that you really think are so important that people should be asking, or that you hear often? Or is there anything out there that you really want to make sure the audience walks away with today?
I'll start, Peter, then you can chime in. But I would say first, to what I think is probably one of the most important is understanding what the application is. Is it clinical, or is it even going to be in a lab, or is it going to be for home healthcare use? If it's not today, is it going to be down the road?
Right.
Because home healthcare, we definitely know that they have to be class 2, Roman numeral 2. And then it's just kind of what Peter alluded to, as far as the medical standards and the question that came in for emissions, to make sure it meets class B and doesn't interfere with the other components in the machine. And that can be done as simple. I've seen it where either the AC input wires or the other wiring internally, even something as twisting the wires, helps cut down on that. You wouldn't think so, but I've seen it. And then you get a call, well, it didn't meet emissions, and it's like you look at the design, and you can kind of help them do some simple mods to help get there.
Yeah, I think Rick nailed it there. That most important is just meeting those requirements of the medical safety standard. Then that has to do with I guess for the customer side, just designing your board correctly to have the right creepage and clearances to match that of the power supply. So yeah, I don't really have anything to add. I think you nailed it.
And we do have a user asking if we can provide a slide deck to get part numbers for the devices. So I'm sure you guys can send something over to this user, of course.
Absolutely.
Yeah, I can put something together as long as I
Awesome.
can grab their email or something.
Yeah, we'll actually
we'll send that on over to you. No worries.
Yes,
We've got you covered.
We will
Perfect.
connect you guys together right after this event. Well,
Awesome.
if there's no more you guys want to share, or there's no more questions from the audience coming in, thank you for joining us today for this live chat. Thank you to our sponsors, Sager Electronics and Recomm Power, and our amazing panelists today. Listen,
Yes.
everyone have a great day.
Hey, you know what? Why don't you let everybody know where they can learn more about Recomm
Yes.
and Sager, and that way we just leave everybody with some information. Peter?
Oh, sorry. So for me, yeah, you can learn more about Recomm at recomm-power.com. We have all of our products listed there, where you can find data sheets and some white papers and then application notes and that kind of stuff. And then if you need any technical support, you can reach me at tech support Americas at recomm-power.com. And we're happy to help you out in any way we can.
Awesome.
And for Sager?
Sager.com or power.sager.com. And I'm regional. There's 11 other of me around North America, but so I'm up in the upper Midwest. But and then the only other thing I'd like to add is Sager is far more than just a distributor. Our facility down in Texas is a complete ISO certified with medical ISO 13485. So if there's any modifications, I mean, we can definitely do it on the output side of the Recomm power supplies. That's not a problem. Sorry, can't touch the AC side. And we're a UL 508A panel shop and safety certified by UL, CSA, TUV, and VDE as well. So if there is any simple mods or even beyond that, custom solutions needed, Sager can definitely do that as well.
Awesome. Well,
Awesome.
I said, everyone reach out to Rick and Peter. Make sure you check out their websites, and now go have a great day.
Thank you, guys.
All right. Thanks,
All
everyone.
right,
Bye-bye.
thank you.
Thanks,
Bye-bye.
Peter. Thanks, Rick.
You're welcome.